So, your time is over. Please hand in your quizzes.
I'll show you how I got mine. I'll demonstrate it to you guys. There's different participation.
5%.
Can you show us how you answered now?
Well, someone's done it.
You got mine.
Oh, you're.
What was the answer? I got 50%.
You got 15%? 50?
50, yeah.
I had no idea how to do this. I got 35%.
So, I'm going to give you the answer.
Yes, let's ask the answer.
I learned to share how much time.
I don't like when it's counting, I get distracted. So is there.
I call this pressure's on.
Took a picture of your test that one.
That was really funny.
Hold it up.
Angela.
Where's mine?
You know how I have the camera? It's not even photography. I call this pressure's on.
No, that is a good picture.
That, yes. I was on the right track.
Was this the answer? I did it twice. So it's not 35%?
It's not 85%.
I wrote the formula, right? Hey, what you see for the
So, because this was your first quiz, I don't assign any marks to it. It was just to show you how we are going to do the next quiz next week. And get you prepared. Because you want to do a good mark in the overall grade in this course. So we don't want to miss even 5%. So starting from next week, we will have such a quizzes every week, except the week that we have the midterm.
Isn't the win series the whole thing?
Sorry?
if I get my
We know that we can use the.
Because this is the way to analyze conditional probability. Whenever you have conditional probability, that means that events are not independent. You have to use the tree diagram so that you can analyze how they are related. But you know, when you get experience in doing this, sometimes you even don't need to do that. So you can just write down the formula and do the calculation. Any questions?
I would keep two, one for you and for me.
So I'm going to start the next topic, which is about random variables. So you are acquainted with the variable in the context of population and sample from chapter 2. This is another context of using the variables. And as you see, it has an additional description, and it is a random variable. So So a random variable is related to a random experiment. You remember what was a random experiment? A random experiment was an experiment which has several outcomes, not only just one. So you cannot predict the outcome before you know the experiment is done. And the random variable is a function that assigns numbers to each outcome of a random experiment. So, for example, if you flip a coin 4 times, you may be interested in writing down all the simple outcomes, which can be shown by H and T to describe the outcomes which are head or tail. But you can also be interested in the number of tails or the number of heads. So if you are, for example, interested in the number of heads when you flip a coin 4 times, then the variable that you are looking into is a number from 0 to 4. Because when you toss a coin 4 times, you may have 0 heads, you may have 1 head, you may have 2 heads, 3 heads, or 4 heads. So the random variable for this random experiment has 5 values, starting from 0, ending at 4. Any questions? Another example. We have already talked about such an experiment of tossing 2 dice. At that time, we were interested in describing the outcomes by writing down both of the numbers which are observed on the dice. But suppose that now you are interested in the sum of the numbers. So you want to record the sum of the numbers observed on the dice when 2 dice are tossed at the same time. So if you think about the sum of the numbers on the 2 dice which are tossed at the same time, the lowest number that you get is 2. Because the numbers on the dice start from 1 and end at 6. So the lowest number you get is when you have 1 on each dice. And then 1 plus 1 will be 2. Starting from 2, and then 3, 4, 5, and the highest number that you can get, maximum number that you can get for your random variable is 12. Because the maximum number shown in the dice is 6. So 6 plus 6 is 12. So in this experiment, tossing 2 dice at the same time, the random variable that we are looking to is sum of the numbers shown on the dice or observed on the dice. Now I want to categorize the random variables. So random variables can be categorized based on the numbers that are assigned to those random variables. We had a conversation about this before when we were talking about the variables. And then, as you remember, we were talking about discrete and continuous variable. Here is the same. So if you are talking about numbers on the dice, or number of hits, or observe when you toss a coin 4 times, these are all countable numbers. Like 0, 1, 2, 3, 4, 5, you can count them. These kinds of variables are called discrete variables. So discrete variables are variables whose values are countable. Continuous random variables are just variables whose values are not countable. For example, we had an experiment before of recording the time that takes to do some job, like certain task. So you use a watch or chronometer and start it at a certain time, and when the task is finished, you stop it, and then you record the time. The time that you record is not countable. You cannot count it. You can have task finished in any time greater than 0, but you never can say that this is the first value for time that takes this task to be done. Because every number, every positive number that you think of, there is still another positive number which is less than that positive number. So there is no beginning, there is no first number, there is no second number. So these kinds of random variables are called continuous random variables. Another example, for example, time to write a statistic exam. When you can't leave the exam classroom or wherever the exam takes place before half an hour. So you have to stay for half an hour. And you have to submit your papers at the end of the assigned time, which is 3 hours. So the minimum time is 30 minutes. The maximum time is 3 hours. But if now you think about 30 minutes being the first value for this random variable, what is the next value? Well, as you see in the slide, it describes. If you think about 30.1 as being the next value after the first value, which was 30 minutes, well, then somebody may say, still you have a number which is 30.001 and or 30.01 and then 30.001, which are less than 30.1. So 30.1 cannot be the second. That's why you cannot assign a second value for the random variable. Same way you cannot assign a third value or fourth value. So you cannot count the values of this random variable. That's why we say the values of this random variable are uncountable. Uncountable means that you cannot count it. When the values of the random variable are uncountable, then we call that random variable a continuous random variable. So again, to make a division between these two categories of random variables, discrete random variables are like number of times that you observe a head when you flip a coin 4 times, or the sum of the numbers that you observe on 2 dice when you toss them at the same time. And continuous random variable is a random variable like the time that it takes to do a certain task, like taking an exam. Other examples of continuous random variables are like height or weight. So you cannot count these numbers. Every number that you can think of, there is a number less than that, there is a number bigger than that, and they are not countable. Next topic that is related to our discussion is probability distribution. So you have a random variable, like the first example, which was number of heads. Second example, which was the sum of the numbers on 2 dice. And third example, which was the time that takes to do a certain task. So you have a random variable and you have these numbers. So how do you assign probabilities to these values of random variable? Like, for example, the simplest example among these is when you flip a coin 4 times. You can have 0 heads, you can have 1 head, you can have 2 heads, or 3 heads or 4 heads. Well, question is, what is the probability for each of these values? What is the probability of having 0 heads? What's the probability of having 1 head? What's the probability of having 2 heads? And so on. And when you are talking about a continuous random variable, like time that it takes to do a certain task. So you may ask this question, what is the probability that this person who is taking this test finishes the test within 1 hour? Or finishes this test within 2 hours? These questions are related to the general idea of how probabilities are distributed for this random variable. The probability distribution can be specified using a table or formula or a graph. Any of them can work to describe the probability distribution for a random variable. And these are things that we are going to discuss. This is just an introduction so that you get acquainted with the idea of probability distribution. Any questions? How we denote the random variables? Random variables, as was described, are functions. So for those who have a good sound mathematics background, they are functions from the set of all outcomes of a random experiment to the numbers. For the discrete random variables, this function has values in natural numbers. For the function who are continuous, for the random variables who are continuous, this function has values in the real numbers. We denote the random variables, which are functions, as specified again, by the capital letters like X, Y, Z, etc. So capital letters are used to specify the random variables, which are functions. And lowercase letters of the same category are used to specify their values. Like if X capital X denotes a random variable, we show an arbitrary value of that random variable by lowercase x. If y, capital Y, is a random variable, we show one of its values or an arbitrary value of that random variable by lowercase y, and so on. This symbol, P of x equal to x, or simply P of x, is used to denote the probability that that value happened. For example, in the first experiment, which we toss a coin 4 times. If I write P of x equal to 4, that means I want to denote the probability of observing 4 heads. In the second example, which we were talking about the sum of the numbers on the dice, when we write P of x equal to 7, we are talking about the probability that the sum of those observed numbers be 7. That's so simple. So P of x equal to x, or simply P of x, denotes the probability of x, the capital X, which is the random variable, be equal to lowercase x, or have value x. So you remember that when we were discussing assigning probability, when we were talking about descriptive statistics, we said that there are 3 ways to assign probabilities to different outcomes or events. Here it is the same. And the same rules exist in the context of probability. So never you can have probability of some random variable being equal to certain number greater than 1. And never you can have it less than 0. So probabilities are always between 0 and 1. The lowest number for a probability of any value for a random variable is 0. And the highest value is 1. And the second rule is that if you write down all the values of the random variables and add up all the probabilities, what you will get, or you should get, is 1. So all the probabilities add up to 1. So remember that when you are assigning probabilities, or you are looking into a problem which is related to the probabilities, always these are rules that should prevail. And if there is something in contradiction to this, there is something wrong. So you have done something wrong, or a document that you are observing, or the problem that you are observing has something wrong. So probabilities always are between 0 and 1. And the sum of all the probabilities should be equal to 1, everywhere. So look at this example. In the US Census 2009, there was this report that the number of households based on the number of residents on that households are divided like this. These numbers are in millions. So it means that for this table, you have households with just 1 member in US at the time of this census, which was 2009, are 31.1 million. Number of households with 2 members, 38.6, and so on. So this information or data is based on the US Census in 2009. we are looking into, or the question is, how can we develop a probability distribution for the random variable which is defined as the number of persons per household. Like we want to find a rule or a graph or a table that assigns probability to numbers from 1 to 6 and also 7 or more. So what's the probability of a household having 4 members? What's the probability of a household having 6 members? Etc. So I want to ask you, before we advance, what do you think? How can we assign? Think about it for a couple of minutes and tell me. How can you label this table? How can you call this table? Can we call it a frequency table? Can we call this table a frequency table? Yeah, it's a frequency table. So, you have this frequency table. What you can add to this table that can help you to assign the probabilities? How should you advance to find the probabilities of each number of this random variable, each value of this random variable? What can we do? Any idea?
Divide the number of persons to the number of households.
Divide by?
Number of households.
Well, you know that one of the strategies to assign probability is using the frequency. You remember? There are 3 approaches to assign probability. And as you remember, there were the classic approach, there was frequency approach, and there was subjective approach. So now you have the frequencies. What approach do you take? Frequency approach. But if you want to use the frequencies to assign probabilities, you should do something a little bit further than the table, than the information that you have in the table. What you should do?
Figure out what the total number of decimals is.
Yeah, divide each frequency by the total number. That means that you want to find the relative frequency. So if you find the relative frequencies, then you can find the relative, you can assign those relative frequencies as the probability for each number for the households. So just you have to add all numbers in this row, find what's the sum of them, and then divide all the numbers in this row by the sum. Then you find the relative frequencies. And that's the frequency approach of assigning probabilities. So that's something that you may look into and do it at home. And then I want to ask you to do this one, which is a little bit simpler, in the class. So you have 10 minutes to do this activity, to develop a probability distribution of the random variable, which is defined as the number of heads when you flip a coin 3 times. So spend 10 minutes on this. And I want to hear from you when you are done. So to begin with, what are the values of this random variable? I assign the capital letter X for this random variable. And the values, if you toss a coin 3 times, you can observe a head 0 times, or 1 time, or 2 times, or 3 times. So you can have one of these 4 values. So what we are looking for is probability of X being equal to 0, probability of X being equal to 1, probability of X being equal to 2, and probability of X being equal to 3. Find a way to assign probabilities to these random variables. Think about the 3 approaches that we have already talked about. You can work in groups and talk with your colleagues and then find a way. You want to join? Emma? You can have a discussion too, you 3. So talk about your opinion, see what is her opinion about this, or what Kyron thinks about this.
One out of 6. 3 of 6.
Just keeps changing, huh?
Don't forget what you used today. What did you use today?
It depends on the first one.
Then you can write the probabilities at each step. So for example, at the first step you have probability of H being 1/2. Second step, again, 1/2. 1/2. Third step, again, 1/2. Each step, the probabilities are the same. Why? Because if each time you flip the coin, whatever you observe, it doesn't affect the outcomes in the next flip. So all the steps are independent, or all the events are independent. So if you want to find the probability of all the 3 events at the same time together, you have to just multiply. So you multiply the probabilities to find out what is the probability of having 3 H's. Is 1/2 times 1/2 times 1/2, which is 1/8. And for this one, again the same. So if you want to find what is the probability of 0, which of these outcomes actually shows you that event? Which of these branches of the tree shows the event that you have 0 heads? So these are all heads. This has 1 head. So no nothing in this branch. You have to start from this event, which is a tail, and then go all the way in the branches which have tail. Tail, tail, tail. So you have just 1 event in which you have 3 tails and no heads. And what's the probability of that branch, by the way? It's 1/8. Because there is just 1 branch, and in this branch, all the 3 flipped coins have tail on their face. So you don't have any heads. That's the event that we're talking about. X be 0. Number of heads is 0. And the probability for that event is 1/8. What about the event that you have 1 head? So if you start from here, you already have 1 head. So you don't want to have any other heads, because the event that you are looking for is the event that you have just 1 head. So you shouldn't go this way, because this is another head. You should go this way. So you go this way. Then you shouldn't go this way, because this is another head. You don't want another head. So you have to go this way. So you have head, tail, tail. What's the probability of this event? 1/8. So you record this as 1/8. Let's find another one. Tail, head, head. We don't want this. We want just 1 head. Tail, tail, head. Yeah, we want this. So you have another one. Tail, head, tail. I mark it. So another 1/8. And what about another one? If you start here, tail, tail, and head. It has just 1 head. Yes, this is what we are looking for. So you have another probability of 1/8. Together you have 3/8. So do this too now, using that probability tree. Well, the marker was not good, so you draw the probability tree in your own paper, and then you observe. Another 5 minutes, work in that and find the probability for x being equal to 2 and x being equal to 3. These are important. Do the example in SNP, or this is the base for the idea that you want to learn. help out the process. So you don't want to find the product point, right? COA. Can you mark the branches that are related to this? Yeah, X is equal to 2.
Oh, for that one, yeah.
Exactly, because when you add fractions.
You have to name them head and tail. The next one is head and tail. Head and tail. So that you can see what are the events that have happened.
That's all you're looking for.
Yeah, well, you don't know how many tails you want. You want 2. So here you have 3 heads. This is not. And head, and tail is equal to cluster. This one. And then head, and then tail, and then head. And then yeah, you have something in your mind, but this is not the way that they're talking. What's even in each branch, so that everybody else can understand So this comes from events that have 2 heads. So suggested values for probability of x equal to 2. What did you find? What's the probability of x equal to 2? 3 over 8? Okay, let's check your answer. Any other suggestion? Any other different value? So let's see. If you want 2 heads, which branches should you look into? So you want 2 heads. This branch is not what you're looking. This has 3 heads. But if you go this way, head, and tail, yes. And then if you go head, tail, and head, yes. If you go tail, head, and head, yes. So how many 1 over 8s you found? 3 of them. So altogether you have 3 over 8 as the probability of having 2 heads. So now that you finish this, you can write a table. You can draw a table and say x and probability of x. So if x is 0, what's the probability? 1 over 8. If x is 1, what's the probability? 3 over 8. If x is 2, again 3 over 8. Do I need to go through all this process and find the probability of number of heads equal to 3? No, if I'm confident that the previous numbers that I found are correct, so what can I do here is just subtract all of these, sum of these from 1. So probability of x equal to 3 is equal to 1 minus 1 over 8 plus 3 over 8 plus 3 over 8, which is 1 minus 7 over 8. And this is equal to 1 over 8. So I can write 1 over 8. Because the probability is, if you consider all the outcomes should add up to 1. They always add up to 1. Another exercise, 10 minutes for this one. Lots of exercises. So, a salesperson calls people to sell the product that he wants to sell, or she wants to sell. Based on the past experience, he knows or she knows that there is a 20% chance whenever he or she calls a customer to make a deal or to close a sale. So, he calls 3 people. This person calls 3 people. So he makes 3 calls. And for each call, he has 20% chance to close a deal. I want you to figure out what is the probability distribution of having 0 sales, 1 sale, 2 sales, or 3 sales. The maximum sale are 3 because he just makes 3 calls. So he may be successful to make a deal with 1 customer, or 2 customers, or 3 customers, or 0 customers. So you can make a deal, 0 deal, 1 deal, 2 deals, or 3 deals. Find the probability distribution for this random variable. The values of random variables are the same as the values that we had here. 0, 1, 2, and 3. But the probabilities are different. Find out the new probabilities. Ten minutes from now. So you can again start with the probability 3. And the first event being making a deal with the first customer or not. And then the second customer, then the third customer. So I use letters S and F for success and fail. Right, the success to make a deal or the fail to make a deal. And I use different colors for the first customer, second customer, and third customer. One question that may help you. Our success or fail for each customer depends on the success or fail with another customer. No, they are independent. So when you want the three events to happen together at the same time, you can just multiply the probability of each of them.
So did you find what you're supposed to do? The values for the probabilities of each event are different. At that time, it was 1/2 for each event.
Now it's 0.2 for success and 0.8 for fail. So for example, if you want to have 3 success, you have a probability of 0.2 for the first, 0.2 for the second, 0.2 for the third. You have to multiply 0.2 by 0.2 by 0.2.
Yeah.
Which branch shows 3 success?
Second call is second branch right there, that's in the green.
Okay,
Third
so
branch.
in each step, what's the probability?
Probability is the first thing.
So 0.2 times 0.2 times 0.2 is whatever number you get is the probability of x equal to 3. So do the left, probability of x equal to 2, or probability of x equal to 1. Yes, and also you have to count how many branches you have with the same number of success. Okay?
That have two successive calls, right?
Okay?
So if you add
Yeah, you
make
you
one
calculate the
probability.
probability, yeah, you calculate the probability of each branch and then you add them up. So what's the probability of x equal to 2? How many branches you have for which you have two successes? One branch? This is another one. So this one, and then you have this S, S. Three branches. So one more, you have two successes. You have three branches. This one. And another one, what's the probability of each of them? This one's success is probably 0.3. And then going to this one is fail, times 0.8. The next one's success is 0.4. And for the rest is the same, just these are like change rates. So you add or you multiply this, whatever number you get, you multiply it by 3. So 3 times this is equal to probability of x equal to 2. So you come to the branches and you multiply the probabilities along the branch. So which one did you find? Or you find probability of x equal to 0? Or which one? That's correct.
Should it even be a 0?
Sorry?
X equals 0. Should it even be? Should that just be 0?
The probability?
Yeah.
Now we have one event which, for which x is equal to 0. And that is f. And the probability for that is 0.8 times 0.8 times 0.8. Sorry, we have this problem because of these computers and you cannot see the whiteboard. I have a limited space in the whiteboard. We can always move if you like, somewhere closer.